Here's something that I have always wondered about, and you may have wondered about the same thing, Will. And you know it's got to get serious when we boot up the ScienceDaily.com on this show right here. But I'm gonna just keep it quick and easy. The concept of getting water, drinking water, water supply, fresh water out of the ocean. Everybody thinks that why aren't we doing that? We got droughts. We can't. We don't have enough water for all the almonds people want to grow to make almond milk. Where are we gonna get all this water from? You had the fires out. Speaking of California, wouldn't this be so perfect? I mean, the oceans look like they got a lot of water.
Yes.
So this is what the average person thinks, but this is a complex process. Goes by the name desalinization. And this is taking the saline, the salt, obviously, out of the water so that it becomes more usable. And there's been a breakthrough. Well, they're going to be able to do it now.
Right.
Well, they're closer. They're closer.
Okay.
They're closer. In the past, part of the issue here was that it wasn't feasible, not because they didn't know how to do it, but it was not cost effective. And not cost effective, not energy effective, to the point where it could be more of a negative impact to actually go through the process because of the energy required that you have to put in to get the water out. You start looking somewhere else because it's like, well, now you got all this new waste that's been generated because you need to bring in all this energy in order to do the thing. The value of water would have to be at a point where it was necessary to do so. You wouldn't want to do it. You would want to find a more efficient approach. So the research team in partnership with DuPont Water Solutions solved an important aspect of the desalinization mystery. Opening the door to reduce costs of clean water production, the researchers determined desalinization membranes are inconsistent in density and mass distribution, which is responsible for holding back their performance, which is the reason you have to pump more energy into it. Uniform density at the nanoscale, that means really small, at the nanoscale is the key to increasing how much clean water these membranes can create. So by the way, this process, they use pressure on the water, hold back the minerals, let the water pass through. That's the idea, but the filter is the key component. And greater uniformity leads to a more efficient process. And that's something that they just discovered because of a lot of guesswork around how this stuff is going to function. And if you and I were scientists, Will, we'd be sitting around like this, trying these kind of things out. But we're not. We count on people like this to figure this stuff out. Now, I don't know. It's not necessarily ready to go in the sense that you're going to see the drinking water pumped straight out of the ocean. But this development and this finding means that they can now start building these filters that have this necessary uniformity to actually start pitching the idea and, I guess, commercializing it.
Well, that's awesome. If we can make it available for all nations.
An increase in the membranes tested by 30 to 40%. They can clean more water using significantly less energy. I don't know. Maybe they can put those fires out or grow more almonds, or I don't know. Wait, can't you? I suppose you can put fires out with salt water. Yeah, that would be fine.
You can do that.
That'd be fine.
You know, the ground will just be salty.
Salty ground.
It's not a big deal.
Yeah. But how do you get the water up there, though? The salt water. If you're up in the inner part of the state, you just got to transport a lot of water. That's not in the water system. See, it gets dry in a drought in the first place because you can't water anything. You have no water. You can't use water because you're short on it. So you can't be watering the lawn.
Mm-hmm.
So it's not very lush to begin with. If you had this tremendous supply of desalinated water pumping through the communities, they could use the water to suppress the dryness, which wouldn't let these fires spread nearly as much
Yeah.
because it would just be part of the water system.
Yeah.
Anyway, it's interesting. It's cool.
Oh yeah.